Alright, in this video we are going to study one more important topic in consumer theory, that is about the measurement of welfare change. Okay, so I put this topic in section number 2.3 of my lecture slide. So this material appears on page number 76, and you can find relevant discussion in our textbook in chapter 3.9 of Musgrave and Green. So the question I'm going to address in this video is very important because it has a very important policy implication, because that is about the people's welfare. Alright, so to introduce the question I'm going to address in this video, consider a price change or income change. Okay? And after this change, we inevitably experience welfare gains or welfare loss. So we might be better off or we might be worse off. Okay? And then the natural question that arises in this context is how to measure such a welfare change. Alright, so to formalize our question, we consider some economic change in the society. Okay? So we may consider some change due to environmental change, for example, natural disaster, earthquake, or we can think of a economic change due to pandemic situation, for example, COVID-19, or we can consider economic change due to some new policy system. For example, new tax system can be devised by parliament members, or new subsidy plan can be implemented by the central authority, or new monetary policy can be implemented by central bank, and so on. Okay, so in those situations, we can anticipate there will be some change in the economic variables. Okay, in particular, there will be change in price factor and wealth, consumers' wealth. Okay, of course, such a change brings about the change in all economic variables, for example, interest rate and so on. But we pay attention to the change in these two parameters because these two are the key for the analysis of consumer behavior in classic economic theory. Okay, so we consider price change and wealth change. More specifically, after this economic change, we assume that price level increases to, so price level changes to from P0 to P1. Yeah? And consumers' wealth changes from W0 to W1. Okay? And we attempt to quantify people's welfare before and after this economic change. And we can do this, for example, using the indirect utility function. Okay? And remember, indirect utility function V tells us what is the highest level of utility obtainable given this situation. Okay, so if we have information about the function V, we can quantify people's welfare using that function. Okay? So if we know the function of firm V, then people's welfare is going to be P0 and W0. Okay, before the economic change, and let me call this U0. Yeah, so U0 stands for the people's welfare before the economic change. Okay? And V of P1, we can similarly assess the people's welfare after the economic change, and let me call this U1. Yeah, so people's welfare after the change. Alright, and so using this function V, we can quantify welfare change as U1 minus U0. So the difference between these two indirect utility functions. Minus V of P0 and W0. Alright, so this is the welfare change in utility because, indirect utility function tells us the some level of utility. Okay, so we can evaluate the people's welfare change in terms of utility, but one major shortcoming of this measure is utility is invisible. Okay, so although we have information about the people's indirect utility function, And although we quantify this difference, say, it turns out this difference turns out to be number 5, it is very difficult to give some, sensible interpretation to that number. Okay, so how do we have to interpret the number 5? Because we don't have a common unit for utility, for the concept of utility, so it's very difficult to give some interpretation. Okay, so it'll be convenient if we can translate this indirect utility into something visible, such as money. Okay, so that raises a question of how to monetarize this welfare change. Okay? And then the answer to this question comes from another value function we studied before, expenditure function. So remember, function E depends on the price vector P and the target utility U. Okay? So it gives us the information about minimum expenditure for this target utility given price vector P. In other words, how much money we need to attain this level of utility, so to attain this welfare given price vector. In other words, what is the monetary value of this welfare U given price vector? Okay, so in contrast with the indirect utility, expenditure function uses money. Uses money. That is well visible. So using this expenditure function, we can quantify, so we can monetarize the welfare change. So that is a basic idea of money metric indirect utility function. That is defined as a composite function between expenditure and indirect utility. So taking a form of E of P, V of P0, and W0. Okay, so it tells us what is the monetary value of this indirect utility, so the highest level of utility attainable in this situation. Okay? Right, so the money metric function is defined as this, defined as the composite function of expenditure and indirect utility. All right. So using this expenditure function, we can re-quantify this welfare change. Okay, so we first quantify the monetary value of U1. That's going to be E of P U1, and quantify the monetary value of U0. It becomes E of P U0. Okay, so the welfare change can be expressed as the difference between these two expenditure functions. So that's the way to monetarize the people's welfare change. Okay, but we have to determine one more thing on this measure, because expenditure function depends on the price vector P. Okay, so we have to think about which price vector we have to use for this measure, because we have two natural candidates, because we consider price change from P0 to P1. So we may use the new price vector, or we may use the old price vector. And depending on this choice, we have two types of measures, compensating variation and equivalent variation. Okay? In CV, compensating variation, we use the new price vector. Okay, so CV is defined as U1, U1, P1, and U0. Okay, so after substituting the new price vector for P in this expression, we obtain the compensating variation. If we substitute the old price vector, we obtain the equivalent variation. So E of P0, E of P0, and U0. Okay. A simple way to distinguish these two measures is, compensation. If you think about compensation, it usually takes place after something changes. So after the outbreak of COVID-19, we have to think about how much compensation is needed for the national people. Okay? So when we compute compensating variation, we use the new price factor. Yeah? So we think this compensation after something changes. Okay? And before something changes, we can think of what is equivalent to this economic change. So the name of this equivalent variation comes from the fact that we use the old price factor for this welfare change. Okay. So in the next slide, I'm going to illustrate the law of each measure one by one. And let me start with a compensating variation. Okay. And for a simple discussion, we are going to consider price change only. Okay. In case of income change, we can easily address that quantification issue, because if people's income drops by $50, then we can say people's welfare drops by $50. There is nothing to monetize, right? But price change is a little bit tricky. So we fix the people's wealth by W. Okay, and then consider price change only. Okay. So suppose that price changes from P0 to P1. And remember the definition of U0, the highest level of utility, before the economic change, and U1, the people's welfare, after that change. Okay? And remember the definition of CV. Okay? So when we calculate the CV for welfare change, we use the new price factor. All right? And then in case of a price change, we can rewrite this CV as follows. Because U1 is given by indirect utility, at price factor P1. So if we substitute this U1 in the first term, then E of P1, V of P1, W, and minus E of P1, U0. Okay? And in the first term, the two base, so the price factor, so the base for expenditure function and the base for indirect utility are identical. And by the duality, so by the inverse relationship between function E and V, we know that this boils down to W. Okay, so it simplifies to W minus E of P1 and U0. Okay, and then W was the minimal expenditure. Okay, for obtaining this level of utility, U0, given the old price factor. Okay, so W can be rewritten as E of P0 and U0. Okay, so with this wealth and given price factor P0, consumers' welfare, highest welfare amounts to U0. So in other words, by the duality between Hicksian and Wallachian demand, in order to achieve this level of utility, and given this price factor P0, consumer needs at least this amount of income, this amount of money. And we didn't change the consumer's income, wealth. This W is equal to the this amount of expenditure. Okay, so this is the CV form. If we consider price change only, and if we consider price and income change at the same time, CV takes this general form. But if we consider price change only, it reduces to the difference between these two expenditure functions. Okay, so we evaluate the expenditure at the different price factors at the same target utility. Okay, so with this alternative form, we can visualize the compensating variation in this figure. Okay, so in this figure, we consider price change of a good one. Okay, so the price of a good one falls because this is the original budget line, and this is the new bottom line. Okay, so we can see that people's purchasing power is improved. Okay, in terms of a good one, in terms of demand for a good one, that means the price of a good one decreases. Okay. All right, and then this was the highest. This is the highest level of utility. Okay, because at with this indifference curve and with this bottom line, original bottom line, we have a tangent point. So at this point, indifference curve is tangent to the bottom line. So it can be regarded as the optimal bundle. That is the optimal bundle before the economic change. Okay, and then if we set the price of a good to equal to 1, the y-intercept of the bottom line is equal to w. Okay, in principle, that is a w over p2, but if we set p2 equal to 1, the y-intercept of this bottom line is going to be w. Yeah, so expenditure at p0 and u0. Okay, the minimum expenditure for this u0 given the old price vector. Okay, then what is the second term? What is the minimum expenditure for the same level of utility given the new price vector? Okay, because we consider decrease in price of a good one, so we pivot this bottom line. Okay, so the slope of the new bottom line is smaller than before, so the bottom line becomes flatter. So with this new slope, we gradually adjust the income to the extent that this new slope, the bottom line of this new slope, is tangent to the previous indifference curve. Okay, so at this point, we have a tangent point. So it can be thought of as the Hicksian demand. That is the solution to the expenditure minimization problem for this target level of utility given the new price vector P1. Okay? And if we set the price of P2 equal to 1, its y-intercept becomes the, that indicates the expenditure, minimal expenditure. That is a E of P1 U0. Okay, so the compensating variation appears on the horizontal on the vertical axis, the difference between these two y-intercepts. Alright, so the interpretation is pretty much similar to the Hicksian compensation when we discuss the substitution effect. So that the Hicksian compensation appears that appeared when we discussed the substitution effect. That was defined as the amount of compensation we have to give up for the consumer, bringing her back to the original utility. Okay, so in order to get back to the original indifference curve, how much we have to adjust the compensation, how much we have to adjust the consumer's income. So compensating variation in case of price change is exactly identical with Hicksian compensation. Okay. So once again, CV can be interpreted as the net revenue of a planner who must compensate the consumer for the price change after that change occurs. So we use the new price vector. Okay, and then that compensation is necessary for bringing the consumer back to the original utility. Okay. So here is one specific example to help you understand the concept of CV. So we have Cobb-Douglas utility with an equal weight on x1 and x2. Okay? And the associated expenditure function looks like this. Okay? That is a linear with respect to u and concave with respect to price vector. Okay? And consumer's wealth is given by 8. And we want to compute the CV due to price change from this price vector to this one. Okay? So we set the price of good to fixed by 4. And we consider price change only for good one. Okay? So the good one, the price of a good one increases from 1 to 4. Okay? And you know, intuitively people get worse off, and we'd like to compute. We'd like to calculate the compensating variation due to this price change. Okay? All right, so let me calculate the CV here. So once again, CV is defined as E of P1 U1 minus E of P1 U0. Okay, so we have to first assess what is the welfare for this consumer before this price change, U0, and after the price change, okay, U1. Okay? And we are given information about the expenditure function. But, by the duality, we can easily recover the indirect utility function. So, remember, V function is the inverse of this E with respect to U. Okay? So, we set given expenditure function equal to W. Okay? And then solving this equation for U, that's going to be this consumer's indirect utility function. Okay, then in order to assess U1 and U0, we can simply substitute the given information. So U1 was the V of P1 and W, and U0 was V of P0 W. Okay, so for U1 we substitute A for W and the new price vector for P1 and P2. Then we obtain 8 over 2 square root of 4 times 4. So that is equal to 1. And for U0, we divide 8 by 2 square root of 1 times 4, which is 2. Okay? So, consistent with our intuition, we can see that people's welfare reduces by half. Okay? Now we monetarize this welfare in terms of money. Yeah, so, using the expenditure function. So, the monetary value of this U1, so E of P1 U1, yeah, because in the case of compensating variation, we use the new price vector. Okay, so we calculate the monetary value of U1 at this new price vector. So that's going to be 2 times 1 square root of 4 times 4, which is 16. Sorry, that is 8. And the monetary value of U0 at the new price vector amounts to 2 times 2 square root of 4 times 4, which is 16. Alright, so CV is going to be the difference between these two. So A minus 16, so that is going to be negative 8. Okay, so the interpretation of this number, that is going to be the net revenue to the planner. So the planner has to give up $8 to the consumer, to bring her back to the the original utility function, the original utility level. Okay? All right. And another way to compute this EV is we may use this alternative form. Okay. In this case, we don't have to compute the U1. That is convenient, right? Because we already given the expenditure function E. Okay. So for the second formula, we don't have to compute U1. It only depends on U0. Okay. Because in case of price change only, we don't make use of the new indifference curve. CV is only relevant to the previous indifference curve. Okay, so that's why it has a very close relationship with the Hicksian compensation in the substitution effect. All right, and then There is one more way to compute this CV that is related to the Shepard lemma. And remember the Shepard lemma tells us the derivative of expenditure function becomes the Hicksian demand. Okay, so here we consider the price change of a good one only. Okay, and remember if we take the derivative, derivative of expenditure function with respect to P1 gives me Hicksian demand for good one. Okay, so if we think about the alternative expression, so E of P0, that is 1,4 U0, and P1 is 4,4, and we know U0 is, we just calculate, that is 2. Okay, so CV is the CV is the difference between two expenditures, but expenditure is the antiderivative of Hicksian demand with respect to P1. Okay, so by the fundamental theorem of calculus, we can express this difference as the integral of Hicksian demand. Okay, so by the fundamental theorem, as we evaluate the function E antiderivative at 1, so the upper what is that upper limit of this integration is going to be 1, and the lower limit is going to be 4. Okay, because we evaluate this antiderivative from 1 to 4. Okay, and the other variables are fixed. Okay, so the price of good 2, that is fixed by 4. Okay, and the target utility is fixed by 2. Okay? So using the fact that this Hicksian this expander function becomes the antiderivative of Hicksian demand by Shepard lemma, we can express the CV as the this integral form of a Hicksian demand. Okay, so given this expenditure function E, we can derive a Hicksian demand. That's going to be 2U square root of P2, and we take the partial derivative of this square root function with respect to P1, and it becomes 1 over 2 square root of P1. 2's are cancelled. It can be simplified to U times square root of P2 over P1. Okay, and then we substitute the value of these two, the given information. U is fixed by 2 and P2 is fixed by 4. So U times square root of 4 over P1. So that can be written as 4 square root of P1. Okay. So you may use the integrator S. So you may want to change the integrator from P1 to S. Does not matter. Okay. So we substitute this Hicksian demand. And the antiderivative of the integrator, this guy, is going to be 2 square root of P1, I guess. No, 8 times square root of P1. 8 square root of P1, and we evaluate this from 4 to 1. So that gives me a minus 16. That is the same amount. Okay, negative 8. All right, cool. So that is a CV, and equivalent variation. For this variation, we use the old price factor. Okay, and once again, in the case of a price change only, now we can rewrite the second term using the fact that U0 is V of P0 W. Okay, so that by the duality, we can see that second term comes down to W, so it can be written as E of P0 U1 minus W. Okay, and that W is the minimum expenditure, still minimum expenditure necessary for this target level of utility given price vector P1. Okay, so this guy can be written as P0 U1 minus E of P1 U1. Okay, so the general form of EV, so when we consider income and price change at the same time, that formula is right here. If we consider price change only, EV can be written this way. Okay? So the difference between two expenditure functions at the same target level of utility, U1, at the two different price vectors. So you can easily find out the major difference between these two measures. In case of CV, we use the old indifference curve. Okay? In case of price change only. Okay? So the difference between these two expenditure functions at this target utility. But in case of EV, we use the new indifference curve. Okay? U1 is the people's welfare after the economic change. Right? So still we set the price of a good 2 equal to 1. Then the y-intercept of this margin line, this guy, is going to be W. So that's going to be E of P1 and U1. Okay. So in order to achieve this level of utility at this new price level, okay, then we gradually adjust people's income, people's wealth, to the extent that, this new margin line is tangent to this indifference curve. And we have a tangent point here, and its y-intercept indicates the minimum expenditure. Okay, when the price of a good 2 is given by 1. Okay, and the first term, so in order to achieve the same level of utility, the new utility, okay, and now with the old price vector, so with the old slope that was right here, the dotted line, and we gradually increase the wealth up to the point where we have a tangent point. Okay, and its y-intercept is going to be E of P0 and U1. Okay, so their difference amounts to the equivalent variation. Okay? So EV stands for the change in the wealth that would be equivalent to the price change before that change occurs. Okay? Once again, we use the old price vector for the EV. All right, so if we summarize our discussion, so if we compare CV and EV, so in this example, we considered, so in this figure, we considered the price decrease of good 1. Okay, so if we draw the two Hicksian demand for different target level of utilities, for different levels of target utilities, U0 and U1, we can see that U0 is lower than U1. Okay? So the Hicksian demand for U1 is going to be above the Hicksian demand for U0. Okay? And if we rewrite this, EV in the integral form, just as we did for compensating variation, then is going to be, so if we consider change in the price of good 1, it can be written as P11, P10, integral from this lower limit to this upper limit of Hicksian demand of good 1. So P1 and P2 is fixed, and the target utility is fixed by U1. Okay. All right. So when we calculate EV in case of price change, right? EV indicates the area between this Hicksian curve and vertical axis. Okay, because we usually put the price, the variable on the vertical axis in the analysis of classic consumer theory. So this integral is going to be area of this trapezoid. Okay, so the area between the vertical axis, price axis, and the Hicksian demand for good one, when the target utility is given by U1. Okay, and the compensating variation, on the other hand, we use the Hicksian demand for U0. Okay, so this amount, so the area of this region is going to be CV. Okay? So we can see that in case of a price decrease, so the target utility increases from U0 to U1. So Hicksian demand for U1 is above the Hicksian demand for U0. We can see that EV is always higher than CV. So in case of deflation, EV is higher than CV. Okay? But in case of inflation, okay, now the Hicksian demand for U1 will be below the Hicksian demand for U1 or U0. Okay, so in case of normal good, the Wallachian demand is flatter than Hicksian demand. Okay, so if we consider this price change, yeah, now we consider inflation, so the other way around. So if we consider price increase from this point to this point, okay, this point to this point, and the total effect is going to be this. That is a total effect. Okay? And the substitution effect, I have to draw another Hicksian demand for another Hicksian demand passing through this point. The substitution effect is only this, and the other part will be captured by the income effect. Okay, so whenever income effect has a opposite sign, opposite movement with the movement of a price change, we have the Wallachian demand rather than Hicksian demand. That corresponds to the case of a normal good. Okay. All right. So in case of price change, so that this one is a this one is a Hicksian demand for a good one for U0. Okay, because at the old price, people demands as much as this for a good one. Okay, and by duality we can find out one Hicksian demand intersecting with this Wallachian demand curve. Okay, and this curve is a Hicksian demand for P1 for a good one, but target utility is given by U1. Okay, so in case of price increase, we can see that Hicksian demand for U1 is always below the Hicksian demand for U0. Okay, because U0 is higher than U1. Right, so the EV is going to be this one. Okay, but CV amounts to the area of this trapezoid. So we can see that CV is higher than EV in case of price increase. Okay. So we can verify this fact in this example. where we consider the price increase. Okay? So if the price of a good one increases to 4, if we can find the EV, we already found the CV. That is a negative 8. CV was a negative 8. And if we find out the EV using this integral form, yeah? So EV is integral from 4 to 1, fixed and demand for good 1, which was a 4 divided by square root of P1. Oh, not 4, because we evaluate the Hicksian demand at this new welfare level. So H1 was the here's the equation. This guy, U times square root of P over P1, but U1 is not equal, so U1 is 1, not equal to 2. So 1 times square root of P2 over P1, but P2 is fixed by 4, 2 square root of P1. So 2 over square root of P1. This is a Hicksian demand for a good one. P2 is fixed by 4, and we substitute new target utility U1, that is 1. Alright, so it is going to be so the antiderivative of this is 4 square root of P1, and we evaluate that from 4 to 1. We obtain 4 minus 8. So that only amounts to negative 4. So from this example, we can verify that in case of inflation, EV, the size of EV is just a half of the CV. So we can verify the fact that CV is always higher than EV. So the interpretation of this before the price changes. So if the price of a good one changes from 1 to 4, and before this change, consumer thinks the equivalent to this price change amounts to the loss of $4. All right, and we do have one more measure. That is a consumer surplus. And remember, consumer surplus is defined as the if we have a Wallachian demand, that is a demand for a good one. So this is a P1. And if the consumer purchases, say, 2 units at the price of 6, and from this transaction, consumer obtains extra surplus as much as this. So if we have this linear demand function, demand curve for a good one, consumer surplus amounts to this one. So CS is the area between area below the Wallachian demand curve and above the market price. So the area of this triangle. So if we consider price change, say from 6 to 4, we can see that consumer surplus increases by this amount, right? So the welfare change is going to be this one, the area of this one. So in the previous figure, if we have this Wallachian demand, consumer surplus amounts to this one. That is always between EV and CV. So with these two welfare measures, we have this relation. In case of deflation, EV is the highest, and CS is the second highest, and CV, compensating variation, gives us the smallest number. And in case of inflation, we have the reverse order. So CV is the highest, CS is in the middle, and EV gives us the lowest number. Okay? So what is the benefit of this consumer surplus? Because volatile demand is well visible. So if we have a well visible demand function, it's very easy to quantify consumer surplus. Okay? But EV and CV are based on Hicksian demand. But Hicksian demand is not that visible. Yeah? Although we have some, we can obtain some information from the Slotskycation, because Slotskycation compares the responsiveness of Hicksian demand and the responsiveness of Wallachian demand. Okay? So by using the decomposition formula, we can infer the shape of the Hicksian demand like this, but usually Hicksian demand is very hard to derive. Okay? But Wallachian demand is well visible, so that is one major merit to have this consumer surplus. So among these three measures for welfare change, the final question is, which measure do we have to use? Okay, it depends on the size of the income effect. Okay, remember the income effect determines the gap between Wallachian demand and Hicksian demand, because in case of this price change, Hicksian demand gives us the size of substitution effect, and the other part captures by the income effect. So the total effect is going to be the sum of these two. Okay, so the gap between Wallachian and Hicksian demand can be thought of as the size of income effect. So if the income effect is very small, we can anticipate that the gap between these measures, becomes negligible. Okay? So in this case, these three measures give us a very similar estimate about the welfare change. In that case, it is always better to use the CS, because CS is based on Wallachian demand, well visible. It's very easy to quantify. Okay? So for commodities whose income effect is small, for example, necessity good, okay? Demand for shoes, electricity, and staple food. Okay, so rice in South Korea. So if we think about the income effect for these necessities, we can anticipate the income effect is really small. Okay, so in such a case, if we want to measure welfare change due to change in the price of these goods, it's always better to use the consumer surplus. But in case that income effect is really large, yeah, for example, luxury goods. Okay, example, supercars, or what is that? What is the example of luxury good? Women's bag, and what else? Okay, so for these goods, income effect is really large. Okay, and we can see the gap between these two measures. So now EV is higher than CS in case of deflation, and CS is higher than CV. So which measure we have to adopt depends on the research question. Okay, we have to adopt the CV if the question is related to how much is needed to compensate. Okay? And we have to adopt the EV if the question is related to what is the monetary equivalent of the price change. Okay? So we are going to discuss one example in the textbook at the live lecture for this discussion. Okay, for the right choice of welfare change measure. Okay, and we are going to discuss one more example that is about the deadweight loss of Christmas at the live lecture too. So I think this video is also very lengthy, so it's about the 50 minutes, but hope you find this video useful, and hopefully this video is helpful for understanding of the two welfare measures, equivalent and compensating variation.